Every time we have gone to Mars, we have never come back. Neither we have sent things back or any of the robots have come back. So it's always been one way. So if you really want to dig in and try to find out whether there ever was life on Mars of any sort, there is really no other way but to bring samples of Mars back and then expose them and work on them with the most sophisticated instruments in the world right now in the laboratories. So for this reason, bringing samples back has been always a holy grail of Mars exploration, but the technology wasn't quite right. In fact, at one time it was scheduled for 2008, but when I became the program manager for Mars, I advocated for canceling it because I didn't think it would be successful. But now we're there. So as you mentioned, this is first of 3 consecutive missions. So the first mission, which is what we sent, and it is going to land in a ancient lake bed,
right.
A crater called Jezero. And also there is an ancient river that in billions of years ago emptied into this lake. And as you may know, when rivers empty into a lake, they, at the mouth, they sort of fan out in something called river delta. And things that they've been carrying, it sort of gets deposited at that delta. So we are trying to reach that delta, land there, and we are taking about 40 test tubes with us. And what we will do, we'll core into that delta, we'll take samples out and fill these test tubes, 40 of them, from a varied locations. And then with the instrumentations that we have on board, we make sure that we take the best possible samples. We first examine them and and then fill the test tubes, and then we just leave them there. We just leave it strewn around the land on Mars. So the second of the third mission, which we will send in about 4 or 5 years, for the first time, it will send a actual rocket, which will lift off the surface of Mars for the first time ever, and we land that on Mars. And since we cannot exactly put it where Perseverance left the test tubes, there is a little rover that goes and will fetch these 40 samples and bring it back to the rocket. There, we will put them inside a tube. Since we were staying with sports analogy, the size of the ball is about a soccer ball. We put all 40 tubes inside that soccer ball size sphere. We put it on top of the rocket and we shoot it off from the surface of Mars into orbit around Mars. So there is now this shiny, bright soccer ball with all the samples inside of it circling Mars.
And let me guess, the third mission is to go and pick up those samples from space then.
You keep that up, and I'm going to sign you up. So,
deduction.
Yes, indeed. That's the third mission. That one will not be done by America. It will be done by ESA, which is European Space Agency, which is representing a consortium of countries in Europe. It will go to orbit of Mars, and in that vast emptiness tries to locate this soccer ball and rendezvous with it, capture it, cocoon it in something to make sure if there's any microbe on Mars, it will not expose Earth with it, and then bring it back to Earth. And there, the real work starts of starting to examining the samples.